In this problem, we're given a quadratic equation to start with, and they want us to take that quadratic equation and factor it. I wish I had a super simple, quick, and easy way to factor an equation, because if I did, I would be the hero to everyone. But unfortunately, there really is just only trial and error. So how we start one of these processes is we take the number in front of the x squared term, so in this case 2, and we multiply it by our constant term at the back, which in this case would be negative 36. So out of there, we're getting negative 72. And from that negative 72, what we're trying to do is find a pairing of numbers that will add to the number in front of our x term, which in this situation would be 1. So I just kind of start at the top and I would do 1 and 72, and that doesn't work, and 2 and 36, and that doesn't work, 3 and 24, that doesn't work, 4 and 18, that doesn't work, 5 doesn't multiply into 72, and then we'd try 6 and 12, and that doesn't work. 7 doesn't go into 72, and then we would hit 8 and 9. And if we look at that pairing right there, that's really going to be the pairing that works for us, because we're looking for a positive 1. So if we have a positive 9 and a negative 8, then we add those together, we're going to end up with a positive 1, which is what we're looking for. So then what you do is you're going to take the 2x squared piece and the positive 1x in the middle, we're going to end up splitting up into a 9x and a negative 8x to add together to give us the 1x that we were looking for in the middle. So what you want to do is you'll choose which number to put in next based upon the fact that you need the 2x squared term and whatever value you put in next to have a common factor. And since 2 doesn't go into 9 at all, we know that 9x is not going to be what we want next. We want the negative 8x because 2 goes into negative 8. So we're going to put the negative 8x piece first, and then we're going to put a plus 9x, and then at the end there we do our minus 36. So we've really just taken this 1x in the middle here and broken that 1x up into negative 8x plus 9x. From there, what we do is we're going to think about these as two separate chunks right now, and we go ahead and try to pull a common factor out of each individual piece. So when I look at the first piece, I can pull a 2x out of the first term and I can pull a 2x out of the second term. So I'm going to pull a 2x out of the front, and that's going to leave me with, on the inside now, an x minus 4. In the back term, again, I look for what I can factor out. I can pull a 9 out of the front, and I can also pull a 9 out of the back term. So I'm going to pull a 9 out of the first, and that's going to leave me with an x, and I'm going to put a 9 out of the second term, which is going to leave me with a minus 4. From here, what you're going to see is that you've got an x minus 4 now in both the front and the back piece. And so what we do here is we factor an x minus 4 out of both pieces. So I pull an x minus 4 to the front, and then what that's going to leave me with is, out of this first term here, I'm going to be left with just a single 2x, and out of the second term, I'm going to be left with a positive 9. And so there's our factored solution. We're looking at x minus 4 times 2x minus 9. The trick on this is you always want to make sure you enter a value no matter what into the boxes. So in the first box, I would enter a 1 for my 1x, a minus 4 into the second box, and then a 2, and then leave it as a positive 9. So I wish there was a better way to do factoring, but it really is just trial and error.